Hi, our project's topic is TMDB box office prediction. We have two team members. This is Jiawei. This is Yuqi. In our world today, the film industry is more popular than ever. But what movies make the most money at the box office, and how much does a director matter, or the budget? So in this project, our goal is to predict the overall worldwide box office revenue of each movie in the data set. So the data sets we have has 3,000 entries for the training set. And originally we have 23 columns, including the revenue as our target column. And among those 23 columns, we have some like JSON text file, text columns, and we have some URL, and we also have some categorical variable. So for example, for the budget, we have it in int format, and for the genres we have it in JSON format, and yeah, basically. And in order to transfer our data into our model, so we have to do some data cleaning and feature engineering. So the first thing we do is that we have to deal with the missing values. So first, for some columns which contains all empty values, we just simply like delete the whole column. And for other missing values, we replace the missing values with 0. And then we pass the JSON format data. We actually like extract the important information and into one or two new columns. And we also created new features from existing features. For example, we have the ratio of budget over runtime, or the ratio of budget over release year. And then we added more features with TMDB provides on Kaggle. Finally, we just get some dummy variables to represent the categorical features. So finally, we have total of 242 columns, also including our target column.
So next step is solution strategy and implementation. So in this step, we have 3 algorithms. The first one is gradient boosting tree. So we implement the gradient boosting tree model from the scratch and make the decision. For implement the gradient boosting tree, we have several steps. First one, we use all of the training data to fit a decision tree. And then we have a for loop. In that for loop, we gather a residual from the previous decision tree and use these residuals to feed a new decision tree. And then we add them together multiple times, like after multiple times iterations, we'll finally get our predictions. And for the extreme gradient boosting tree, we also implement from the scratch. And there is different from the gradient boosting tree, which is the last step, which we add all of the tree together as an ensemble model. But for the extreme gradient boosting tree, it's calculate the scaled sum of all of the decision trees and get the predictions. And the next algorithm is a stacking model, which is a mix of XGBoost, light boost, and cat boost together. which means we get the prediction result from those three models, and then add them together in a distribution of 40%, 20%, and 40% together. And the graph on the left shows the feature importance, which we get we get the result from the model. Here we just list the top 20, so we can see the most important one is the budget year ratio, and next is budget, and also it includes release year, popularity, and other features, and which means those features could have a high correlation with our target variable, which is box office revenue. Then come to the result part. So for the gradient boost algorithm, we tried then, and the result is not very good. So, and then we try to use the extreme boost tree, but for that one, it takes a long time to run, and we don't think that's is optimized. So our final model is the stacking model, which is a mix of the three boosting algorithms, and that one we get the root mean square log error, which around 1.70714. So, and also we get the ranking is 42 out of 864 teams. So for our next step, we're gonna find a way to optimize our XG boosting algorithms to make it be more faster. So we could use that to do the prediction, or we can try to use another combination, another distribution of the three algorithms to mix them together to see whether we can get a better performance. So that's it. That's all. Thank you.